Yeah, so we are going to continue 1990 AMC8 and we are going to tackle question number 19. Okay, there are 120 seats in a row. What is the fewest number of seats that must be occupied? So we want the least number of seats that must be occupied. So the next person to be seated must sit next to somebody, right? So if there's a person seated next, he should always sit next to somebody, and we should have the fewest number of seats to be occupied. So for this, I'm going to say I have two seats empty, and then I'm going to fill two seats with people, right? Then I have two seats empty, then the next two seats with people. So this makes sure that every person sits next to somebody else, but after that there are like two seats empty, right? So there will be two empty seats, two people. So what I'm going to do, just going to divide 120 by 2, which will be 60. Half of it is occupied. So my answer option is D, 60. This is just because uh, next person must be seated next to somebody. Okay, if this were not there, okay, saying that this were not, then we can even get the answer as 40. So in that case, I'm just telling this to you extra. So in that case, this is your answer. Okay, for this question, this is the answer. But if this statement were not there, what this will mean is we can even say unoccupied, occupied, unoccupied, unoccupied, occupied, unoccupied. This also is possible. So if this is the case, I will divide 120 by 3, which will give me 40. Right? So for every 3, there's only 1. But in this case, the next person to be seated must sit next to somebody. This is not satisfied, right? So that's why I'm not choosing this as the answer. Okay. Now going to the next question. Annual incomes of 1,000 families range from $8,200 to $98,000. In error, the largest income was entered on the computer as $980,000. Difference between the mean of the incorrect data and the mean of the actual data. Okay. So first we take S to be the sum of all incomes except the last one, or the largest, because that is where you have made a mistake, right? So now if I do this, then my actual mean is going to be S plus 98,000, because 98,000 is the correct amount, right? Divided by 1,000. Okay. Now my incorrect mean would be S plus 980,000 divided by 1,000. Okay. Now I'm going to find the difference between both the means. So I'm going to say S plus 980,000 divided by 1,000 minus S plus 98,000 divided by 1,000. Right? So S and S is going to cancel because 1,000 is already the LCM, right? And then I'm just going to say 980,000 minus 98,000 is going to give me 882,000 by 1,000. So this is nothing but 882, which is answer option A, $882. Got it? This is the difference in the mean of both the data. Going to the next question. A list of 8 numbers is formed by beginning with two given numbers. So they are given at the end. Each new number in the list is the product of the previous two numbers. So this two multiplied will give you this. So basically, if you want this divided by this is going to give you this. Find the first number if the three numbers are shown. Okay. So we are going to divide. We are going to back calculate. So we are going to divide each number. So let's see what comes. So 64 divided by 16 is giving me 4. 16 divided by 4 is giving me 4. 4 divided by 4 is giving me 1. 4 divided by 1 is giving me 4, right? And 4 again, we are going to divide this 1 divided by 4, right? So this is going to give me 1 divided by 4. So my answer is going to be 1 by 4, which is answer option B. So you just keep dividing, right? And then we'll end up with 1 by 4. So that's your answer. Going to the next question. Several students are seated at a large circular table. They pass around a bag containing 100 pieces of candy. So I have candy, which is 100 pieces. Okay. Each person receives the bag, takes one piece of candy, and then passes the bag to the next person. If Chris takes the first and the last piece of candy, so Chris is going to get first piece and the 100th piece. Okay, which means so 99 candies are passed in the circle, right? So 99 is a number which is correctly passed in the circle without any remainder. Okay, without remainder. So the number answer should be divisible by 19, should divide 99. And there's only one answer which does that, B11, right? So your answer option is B11. None of the others will divide 99 correctly. It will leave a remainder which we don't want. So that's your answer. Going to question number 23. The graph relates the distance traveled in miles to the time elapsed in hours on a trip taken by an experimental airplane. During which hour was the average speed of this plane the largest? Okay, so this is time and this is distance, right? Now when we have to calculate speed, this graph, okay, wherever the graph is the steepest, so let's just mark the points. So this is 1, this is 2, this is 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12, right? So these are the points, but the steepest part of the curve is this, right, between 1 and 2. So between 1 and 2 second, this is your uh, you know average speed of the airplane was the fastest between these two because the curve is the steepest here. Okay, going to the next. Three triangles and a diamond will balance 9 dots. One triangle will balance one diamond and one dot. How many dots will balance the two diamonds in this balance? Okay, I'm going to calculate this as a algebraic equation. Okay, so I'm just going to say I'm going to keep triangle as A, then I'm going to keep diamond as B, and I'm going to keep the dot as C. Okay, now we have to find out, what do we have to find out? 2B, right? This is what we have to find out. 2B is equal to dash C, right? How many C? We have to calculate B in terms of C. That is what we need. This is a dash, okay, not a minus. Now, or we'll put a question mark here. How many C? That is what we need. So let's calculate now. So we are going to write this in terms of algebraic equations. So I'm going to say 3A plus B is equal to 9C. Okay, this part. Then I'm going to say the second equation, A is equal to B plus C. Okay, now in the first equation I'm going to substitute the second one. So I'll say 3 into B plus C plus B is equal to 9C. So it's going to give me 3B plus 3C plus B is equal to 9C, which is nothing but 4b is equal to 6c. Therefore, 2b is equal to 3c. You see this? I got 2b and in terms of c, which is 3. Okay, that's my answer, option C. Perfect. Going to the next question. How many different patterns can be made by shading exactly two of the 9 squares? Patterns that can be matched by flips and turns are not considered different. That means symmetrical patterns are not considered different. They'll be the same. Okay, for example, the patterns shown below are not different. So see this one. Okay, now this and this is symmetrical, right? Across the horizontal line. They are considered the same, right? They are not considered different. So if you turn, so it will give you symmetry, right? So the symmetrical patterns, they are considered to be exactly the same. So we should be careful while doing this. So now how I'm going to approach this is, let's just take this. Okay, now what I'm going to do is I'm going to draw a diagonal here like this. Okay, now the first one I'm going to take is this. Okay, this is one square. Now the second square can either be the middle one, this is my first square. So the second square can be this or this. This is one option. Correct? So how many possibilities do I have here? So I have, so first the square I'm taking is a vertex. Vertex square. Okay. So we have 1, 2, 3, 4 vertex squares, right? So I'm going to take that my first square is a vertex. Okay. So now if this is a vertex, this case, so one vertex and two in the diagonal, I have two cases, two possibilities, right? So I'll put possibilities here. When the first square is a vertex, when this is in the diagonal, I have two possibilities. Now, if it is here, okay, so I have one possibility, two possibility, three possibilities, correct? Non-diagonal. So now if I have three here also, but because this is symmetrical, I cannot count this, correct? So I'm going to put 2 plus 3. So how many total possibilities I have here? I have five possibilities here. Okay, now I'm going to take a possibility of a first square being a non-vertex and an edge. Non-vertex edge square. So let me draw this once again. Okay, now when I say non-vertex edge, then it is the possibility, one of the possibilities is this, right? It's a non-vertex, but it's an edge square. Now when I have this, the first possibility that I can do is, I don't want any of it to be vertex because vertex is already covered here. The second will be either here, which is non-vertex, no, but an edge, right? So this is one possibility. Okay, so I'll put one here. Then there is another possibility, which is another edge, which is this. So this and this. So I'll put one more here. And there is another possibility, which is a non-edge, which is this. Right, everything else is duplicate, so this is symmetrically duplicate. If this is there, nothing else can come. And this vertexes are already covered, so 1, 2, 3, only three possibilities. So I'll put one more. Here's three. So totally I have 5 plus 3, totally 8 possibilities. Okay, and this is your answer, C8. Got it? So I've just taken two cases, one vertex square and a non-vertex edge square. That's all. Oh, I think we are at the end of the paper. Thank you so much. Have a nice day.